And now for the number one most common question that I get asked: where do you get this book? Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my Pennsylvania A3 switcher locomotive this week, and I'm going to get all of the forward valve gear attached, connected for realsies with all of the right pins and hardware and stuff. We've got a lot of little pieces of hardware to make, so let's go. I have 14 little pins to make to hold all of this valve gear together and replace these janky little brass screws that I've been using for mock-up. In addition, there are 600 of the smallest E-clips you've ever seen. You actually only need 12. The extra 588 are necessary because for every one that you successfully install, 49 of them will go zinging off into orbit. Now, making all 14 of these pins is actually not that exciting. They're all extremely similar. It's all stuff you've seen me do lots already on this very project. So rather than talk you through making all of these tedious pins, I thought it might actually be more interesting to do a little bit of a Q&A on the locomotive. I get a lot of questions about this project, and it's been a long time since I've answered any of them. So let's go. The first question is, why brass? There's a lot of brass on this locomotive, and obviously brass is expensive, so wouldn't it make more sense to make all of these pieces out of steel? And there's a lot of reasons for that. I should say this is an emblematic question of the types of questions I get because I've been very fortunate with my channel to introduce a much larger audience to the hobby of model engineering. So things that are taken for granted within a very niche and somewhat insular hobby are news to lots of folks who've never seen this kind of stuff before. So the reason that we use brass is mainly because brass is extremely pleasant to model with. It machines extremely nicely, it's very forgiving, it doesn't need a lot of horsepower or specialty tooling to machine. You can take heavy cuts on small, light hobbyist equipment with it. It's very easy to get very nice finishes. It solders easily. You can silver solder it and soft solder it. It's very easy to shape and form, but it's still very strong. So you can make complex sheet metal parts that are still very strong with very simple equipment, and so on. Steel is of course much cheaper, but steel is more difficult to machine, slower to machine on light-duty tooling like this, much more difficult to work with the sheet metal part of it. You need big sheet metal tools or a lot bigger hammers and oxy torches and things to work with heavy sheet metal parts, so it's just overall a lot more difficult to work with. A nice little side benefit of brass also is that brass is heavy, heavier than steel in fact, and weight is an unmitigated good thing in locomotives. The tractive effort that a locomotive can produce is very much a function of how heavy it is, so the heavier you can make it, the better. And in fact, as you'll see towards the end, we'll be filling in a lot of the empty space of the locomotive with chunks of lead or brass or whatever else I've got lying around that's real heavy. Next, I'll answer a group of questions I get around general appearance of the model. People ask, why is this detail different than this photo that I found? Or why is the finish not the way that I would like it with regard to painting and polishing and those types of things? Model engineering is very much an art of taking a real object and scaling it down in a way that gives the impression of the original without being a perfect copy of it. It's literally impossible to simply scale down every nut, bolt, and piece of angle iron and whatever on a locomotive and have it come out the same at this smaller size. Not everything scales down the same way, the physics don't all scale down linearly, and lots of things when you scale them down just stop functioning in their original purpose. There also just isn't enough space for all of the bolts and things that the original might have. So what we're doing is kind of a 3D version of what model railroaders call selective compression. When you're modeling a railroad, let's say an HO scale, if you modeled the full main line of a section of the Canadian Pacific Railroad in your basement, well, your basement would have to actually be like 300,000 square feet if you actually modeled every mile of track at 1/87th scale. So you can't physically do that, and so you choose the most interesting areas to model. You model the yards and the towns and the big bridges and the mountain passes and so on, and all the boring track in between, you just kind of compress it out of existence, you push everything together. And we're doing the same thing in model engineering. We're taking all of the uninteresting bolts and expanses of sheet metal and whatever and just kind of compressing those away and just rendering in metal the smoke box rivets and the chimney stack and the valve gear and the windows on the cab and the interesting bits that really make it look like the locomotive. But if you start zooming in on photos, not every detail is going to be perfect. As far as finishing choices, there's lots of ways that model engineers finish their locomotives. Lots of people do like the look of brass. Of course, we all like brass, right? It's beautiful. And lots of model builders will just polish the brass and make it look beautiful for its own sake. And that's fine if that's what you want to do. It does make the model look more like a clockwork toy rather than a shrunk down copy of the original locomotive. So my personal preference is to make it look more prototypical. So that's why I'm covering up all of the brass with paint and powder coat and so on. I always get lots of questions about that because yes, the brass is really nice, but I'm making the aesthetic choice to paint everything, and that's, what I've chosen for this model. But lots of people make different choices. You are welcome to make different choices as well. A little more on that topic of the model not looking exactly like photos that people might have found of the Pennsylvania A3 switcher online. First of all, I'm building 2 Kozo's drawings. Now, that's kind of a shortcut for beginning model engineers like myself, but traditionally what model engineers typically do is they start with photographs and actual engineering drawings of the thing that they're building, if available, and they develop their own set of scaled down drawings and build to those. And in those cases, you're choosing what details you think are important to include in your drawings, what proportions you want everything to have, and so on. And that's a lot more work, obviously, to develop your own set of drawings. You're doing what Kozo has done when he wrote this book. And again, that's not something that I'm quite ready for, and I don't have a subject that I'm willing to devote that many years of my life into doing. So I'm choosing to build Kozo's exact design for this particular A3 switcher, which he has developed the drawings for from some specific example of this locomotive. And that last detail is important because locomotives are far from all the same. I think nowadays we're used to things like cars where you look at 17,000 1997 Chevy Malibus and they're all virtually indistinguishable. Locomotives were not built that way. They only built half a dozen or a dozen of many of these models, and they were all modified for the needs of the particular railroad that they were being sold to. And after they were acquired, the crews that operated them immediately started changing everything. They added and deleted steps, and they rearranged railings, sometimes intentionally, sometimes less intentionally, and every locomotive very quickly acquires its own personality. That's why when you talk to model engineers, they don't typically say, oh, I'm building a 464 Hudson. They say, I'm building 2816, the Empress, which is a very specific 464 Hudson. It's a locomotive that they have a lot of photos of to look at, and perhaps they've acquired the original drawings for it from the Railroad Historical Society and so on. So modeling a very specific locomotive narrows the problem down and gives you something to focus on and something to choose details from for your model. This topic came up a lot back when I was doing the railings on the tender early on in this series. I had a lot of folks complain that my railings look different than whatever particular photo they Googled. But if you Google photos of the Pennsylvania A3 switcher, and in fact you should go one step further and go to the Pennsylvania Railroad Historical Society, because online there actually aren't that many pictures of most of these steam locomotives. People are just reposting the same 4 photos all the time. If you get a large collection of these photos and compare them all, you'll see that basically no 2 of them had the same railings. So saying my railings are wrong or those railings are wrong doesn't really have any meaning. As long as they're within the spirit of the locomotive or they match a particular instance of the locomotive, then they're correct as far as correct goes. I'm very hesitant to use that word correct because despite what the rivet counters say, there is no correct or incorrect in model engineering. At the end of the day, these are all aesthetic choices. These are all choices of selective compression, and we're all applying our particular view of a locomotive onto the final piece that's been scaled down. Because there is, as I said, no perfect way to scale down a full-size locomotive to 1/16th or 1/12th or 1/8th or whatever scale you are building at. Another common question is, how many hours have I spent on this locomotive and how close am I to being finished? That's pretty difficult to say. I don't think any model engineer could probably tell you how many hours they've spent on their locomotive, and whatever number they give you is probably wrong by a factor of 2. In my case, however, I have the unusual situation of having filmed it all, and so I kind of have a vague, rough way to estimate it. Through many years of doing this YouTube channel, I've learned that a minute of video roughly maps to about an hour of shop time. So if you see a 20 to 30 minute video, you're looking at 20 to 30 hours of work in the shop, plus 10 or 20 hours of video editing after that. But of course, we don't include that if we're just talking about the work. Now, of course, setting up cameras and such does slow me down a little bit. So I'm going to be a little bit slower than a model engineer who isn't filming everything. And I'm also less experienced than most model engineers, so that is also going to slow me down. The more you do this, like anything else, the faster you do get at it. So I haven't done the math on this. You can look at the playlist so far and add up how many hours that is. I'm guessing it's somewhere in the neighborhood of 1,000 or 2,000, somewhere in there. And I'm probably closing in on halfway finished. I'd say once the valve gear is running on air, I would comfortably call that half finished, maybe a little bit over half because I have finished the boiler. So we're probably 2/3 of the way finished at that point. This is all very rough. I really can't say for sure, but it might look like we're further along than we are, but there's actually a lot of infrastructure to do yet. We have a lot of plumbing, we have multiple pumps, we've got a lubrication system, of course we have the cab, and there's the smoke box infrastructure and all the pieces and parts that go into the smoke box and the chimney, and so there's a lot more to do yet, a lot more detailed parts, the railings and lots of hand levers and controls in the cab and all the plumbing and so on around that, so there's perhaps more left to do than it might appear. A related question I get asked a lot is how much does all of this cost? And well, I mean, this is definitely one of those hobbies where if you have to ask, you probably shouldn't get started. Now, assuming all of the equipment is already on hand, obviously there's a lot of overhead in setting up a hobby machine shop, but even assuming you have all of the equipment, I mean, I'm not going to lie, it's a pretty expensive hobby. It's a lot of brass and copper involved. Brass and copper are not cheap. It's a lot of tooling involved. You go through a lot of end mills over the course of building a locomotive. So, I mean, I wouldn't even know how to put a price on it, honestly, because the other thing about this hobby, or building a locomotive in particular, is that it takes so much time and the cost is very spread out over a long period of time. So I'm sure every model engineer would be shocked at how much they ended up spending at the end. I'm guessing somewhere in the range of a small motorcycle, something like that, as far as total cost of everything all in. But you don't really feel it because you're spending it $100 here, $200 there. The largest single outlay I've had so far was, I think, probably about $1,500 worth of copper that went into the boiler. This would have been 2019 prices, something like that, so I'm sure that's all changed. Price of copper just keeps going up. But as I say, you don't really feel the cost because it's so spread out. But I'm sure it's substantial, and there's not really any getting around that. Now, that said, there are ways you can save money. For example, you can use a lot more steel than I'm using, which lots of people do. The frames and the axle boxes and lots of the stuff that I built out of brass, you could certainly build out of steel. It would take longer to do, of course, but you can trade money for time in that sense. You could build it smaller. A smaller scale of locomotive obviously uses less materials. So 3.5-inch gauge is about as small as most people go, but if you still want to build live steam, there are O-scale live steamers, for example. That is possible. I don't know if I've ever seen HO scale live steam. It gets pretty difficult to make everything keep working at those scales, and you're really talking about watchmaking at that point when you're building that small. But people do it, so there are other options. You can also build simpler models. You don't have to build locomotives. You can build stationary engines. Casting kits, for example, are pretty reasonably priced. Cast iron is a lot cheaper than brass, so that's another way to save some money. Or build smaller locomotives. You can build little porters. You can build little donkey engines. There are simpler locomotives than this switcher. Of course, most people actually go bigger. People like to build big mainline passenger locomotives and such. But if you want to build a normal locomotive, an 040 switcher is about as small as you can go. And now for the number one most common question that I get asked: where do you get this book? And that is an unfortunate situation. When I started this video series, 2.5 years ago now, the book was easy to get. It was still in print. You could go on Amazon, you could go on Abe Books, you could go on any bookstore just about and buy it easily. You could buy it directly from Village Press. Super easy to get, not expensive. Well, since I started this video series, the book has gone out of print and it suddenly got very, very hard to get. So I get a lot of people asking about that. Now I have some good news on this front. I asked Village Press about this because I get so many questions. And as of 2025, this recording, they say they are going to do a reprint of this book. So it is coming back. They were not willing to say when, but I imagine if you email them and express your interest, they might accelerate the process a little bit. I'm sure they've gotten lots of inquiries since I started this video series about it based on how many people have asked me where to get it. So the book is coming back, but as I say, wouldn't hurt to throw Village Press an email and ask when it might be available. But please be nice to them and don't spam them or do anything terrible, please. I've had a few people ask if I've ever spoken to Kozo Hiroka, the author of this book, and I'm pleased to say that in fact I have. Actually quite recently, as of this recording, he emailed me out of the blue. I wondered if maybe he was watching the video series. I don't know. I didn't know, rather, but it turns out he is, and he sent me a very, very nice email applauding me on the quality of work that I'm doing, which is extremely kind of him to say that. Of course, everything looks better on camera, so I think it's not as nice as many other people have built this locomotive, but it was very kind of him to say that, and I really appreciated receiving his email. So I will continue to push his work on my channel because I think his books are phenomenal, and everybody should buy them, even if you don't ever plan to build all of these locomotives. I have all of his books, and I mean, I will only ever build one or two of them, I'm sure, but they are such works of art and such a joy to read that you should definitely buy all the ones that you can get your hands on too. Some folks have asked if I will build another locomotive after this, and if so, will it be the same size? And I hesitate to say this now because I don't want to jinx it, but I would like to build another one. I'd like to build Kozo's new Shay. The Shay is actually my favorite locomotive by far. I love logging locomotives, geared locomotives, and the Shay in particular. And Kozo's model of it is very, very nice. And I would also like to build it at a larger size, perhaps 4 3/4 gauge, which would be the next size up effectively that my club track has. However, the boiler is a barrier there. I don't believe I have the equipment or the skills to build a larger scale boiler, so I'm considering some options there. But if I can come up with a satisfactory solution for building a larger boiler or acquiring a larger boiler in some way, I would definitely like to build a larger locomotive, because as fun as this little one has been, I think having some larger components to work on would be nice. Some folks have asked how heavy this locomotive is going to be when it's done. That is hard to say. It's getting pretty heavy already. I would say we're somewhere north of 50 pounds right now, and it's going to keep getting heavier. When it's done, it will still be light enough for one person to lift. At least the locomotive and the tender separately can be lifted by one person. I think lifting them together might be too much for one person. Of course, it's going to be in a shipping crate as well, but it's reasonably manageable by hand. Larger scale locomotives that people build, the 4 3/4 and 7 1/4, 7.5 inch gauge locomotives, those are very much like owning a motorcycle or a sports car. At that point, you need hydraulic lifts and you need a truck or a trailer to haul it around. It's a whole different ball game. But one of the nice things about 3.5 inch gauge is it's still quite easy to transport to and from the club for operating it. Some folks have wondered, how do I stay motivated when you're building something that takes multiple years like this to build and progress is so seemingly slow? How do you keep the motivation going to work on it every day? I think the answer to that is right there in the question, actually. It's a bit like running a marathon. You don't think about the whole thing all at once. You just think about the next goal, the next part that you're going to make, the next cut that you're going to set up. You've always got small goals that you can focus on. And if you learn to measure your progress in smaller goals and don't think too much about the overall goal, then you don't get overwhelmed. And the other thing that helps me is I have a lot of side projects. I mean, you see the videos on this channel. I take a break for a week or two and I make a new piece of tooling, or I make a little side toy project or make something for somebody else or whatever, take little breaks. And then I'm motivated to get back on the locomotive once again. This is an exciting moment because now with all of these pins installed, I can actually show you some of the actual valve gear in action for the first time. So first of all, if I swing the expansion link the way that the return crank will do, you can see the full normal valve motion. You can see that that's how the valve is going to be controlled, and that's producing all of the valve motion needed to run the engine. Now, if I spin the wheels and leave the expansion link alone, you can see this little bit of extra valve movement that is now in there, and that's the lead. If you remember from my wall shirts video, the combination lever is combining the movement of the expansion link and the return crank with the movement of the crosshead to create the correct valve lead and the correct valve travel for all operating conditions. That's the secret sauce of wall shirts, and we can now finally see those two components in action. I can't actually show them being combined in real time the way they will do on the final locomotive, because of course we don't have the return crank and the eccentric rod built yet. But those are coming soon. I hope you've enjoyed this little real-time machining demo and Q&A session. And the valve gear is really basically complete at the front of the locomotive now. We just got to do a couple more pieces at the back of the valve gear, and this thing will be running on air. So exciting. Thank you for watching. Thanks to my patrons for making it all happen, and I'll see you next time.